Welcome, everyone. We are going to start just in 2 minutes. Good to be. You all are on the time, so that's wonderful. Welcome on the very specific session. Welcome, everyone in the call. We are going to start pretty soon. Good to have you in specific after school time in afternoon towards maybe evening.
One, two, and also here.
I think let's start, correct? Aggie, Karen, shall we start? Or just people are logging? Let's 1 more minute. Let's admit everyone and then we can move forward. Okay, so let's begin. Before we start jumping in our program, we would like to start our talk with the land acknowledgement. So as everybody aware, we talked about the land acknowledgement always. Seneca would like to acknowledge the land on which its buildings are housed and where the students, faculty, support staff, and member of the public gathers. This land is the traditional territory of the Mississaugas of the Credit First Nation. We are the guest on this space, and it is our shared obligation to respect, honor, and sustain the land. Thank you, Aggie, for on. Okay, now many people are joining the call from the different semester, different background. Some of you already know that what is NEM, but it started with the NEM is National Engineering Month, and they start this tradition from 1992, almost before 20 years, that we celebrating the engineering excellence. The engineers and engineering, the people associated with the engineering make a significant contribution towards the humankind. So we cherish that hey, whatever they did it and whatever they're continuously striving towards a lot more. There are a few examples you can think of: CN Tower, iPhone design, everybody. So the engineering has a significant contribution towards that. So there is a special association. We are extremely thankful for the National Engineering Month. They are coordinating these things. So one of the partner is NEM. The other partner, we do have this, School of Engineering, the School of Electronics and Mechanical Engineering Technology, SEMET, and their faculty member had organized this program. So I would like to, let's start introduction with one of my colleague, Aggie. Aggie Stopka. She is a professor of the computer engineering and a very young and dynamic professor. And she is a good horse rider. So welcome to on the call, Aggie. That's wonderful. The second professor, which we do have, the Karen Craig. She is teaching lot of interesting subject, and she is mentoring many students for many different ways. And she mentored the student for participation skills for trades, and summit win the gold medal. So we have such an excellent professor as a part of the summit. And my name is Dr. Rakesh. I am teaching automation and robotics. I am the part of the summit team. And along with that, we miss one of our program manager, Neosa. She was the backbone for this program. She had something, so she could not able to, came this program, and under the great leadership of the Romel. So we do have the almost 100 plus students, 100 plus faculty member, and 1,700 students. So it's a quite accomplished big school. Associating right now, they're working with the certifications, post-graduation diploma, and diploma courses, working with building science, industrial design, automations, electronics, computer engineering, many different fields. So as a partnership, we work towards these directions. Now, the last thing, that why we met today. What is the purpose of today's discussions? I am really honored that two of my old students are here, and now they are no more students, but both of them are very nice professional. And they are going to give you some guidance. That's one of them is a Malo, but another is a devil. Before I introduce to them, I would like to talk that why we are here today. I was reading an article by the Canada Statistics. They're talking about that whenever any employer want to hire any graduate, what they are looking for. They're looking for 60% soft skill and 40% technical skill. I never know when I be a part of this program. So the point is, there are so many different things which you can right now put your effort and learn and grow and progress. So when you go in the job market, you are well prepared. So our goal is not just only want to teaching the subjects, but we really want to make sure that, hey, you really understand what is the philosophy, or what are some of the things which we require. May not be, we do not have that much, experience in current trends, but these two experts, they are going to talk about that. I was reading somewhere, it says that what is a common thing in Apple or Google or YouTube or Michael Phelps? What is a common thing? The common thing is their discipline, their routine, eagerness to learn new things. That makes you on the top. And we really want you to be in that list, and on and on. So that's why we do have the two, young, dynamic, and dashing personality. Let me start talking with the Malo. He was a graduate from Seneca 2014, just a couple of years back. Right now, he's working as a sort of manager. He's establishing new assembly lines, working with designing a lot of electronics things. At the same time, other than the designing, he's working with many different area as well. He is right now, their main client are GE, Honeywell. Specifically, they're dealing with the big company of the automation, aerospace, and medicals. So let me bring up the Malo on the stage. So let me spotlight the Malo. Then our second guest is a devil. He is working with government of Canada. That's always fascinating. Working in specifically frequency and time domain, and is maintaining the time lab. He was explaining that if you really want to know exact time, so you can call the particular number, and he is doing such a great things. So he used to be our student as well. So we do have the two speaker, Malav and Deval. We're really proud of them. Both of them are excellent students, very mature, humble, and really great professional. And at the same time, I would like to invite Professor Egi. She is going to take an interview of this, both the industrial experts. Keep your pen and paper ready. They are going to give you some of really amazing advice. So over to you, Egi.
Thank you so much, Dr. Rakesh. I really appreciate that intro. We're going to get into it. What we're going to do is we're just going to have a little Q&A session with our guest speakers today, with Deval and Malav. And if you guys do have any questions for them, if you can post them in the chat, and Professor Karen will kind of go through them, and at the end of our Q&A, we will ask those questions to whatever time we have, we'll ask those questions to our speakers. And I'm sure there's some burning questions, but without further ado, I just wanted to, we're just going to kind of start off. We're talking about National Engineering Month and how, engineering technology is a part of that. It is a part of engineering in general. And both of our speakers today, they went through the process of becoming technologists. So Malav, I'm going to start with you. What does engineering technology mean to you? What does that mean in the engineering field?
So for me, engineering technology means, when you apply the technology and it's more hands-on, not like a lot of theoretical knowledge, but like hands-on, like let's say, for example, if you're working as a technician or technologist, like working with the instruments, working with the calibration equipments and all kinds of stuff, like depending on which technology field you are, like if you're as a computer programmer, then you're programming and using like different languages. If you're in electronics field, then you're using different testing instruments. And then let's say, like depending on what kind of, then I have few people I know from civil, they are doing all this road mapping, road construction. So basically like an applied engineering where you are putting more time on hands-on, that's kind of what I mean from engineering technology.
I love it. Devil, what do you think? You're muted, my friend.
Yeah, the engineering technologies, from my perspective, it's the same Malav spoke, that it's more on hands-on, but whatever the researchers or scientists or engineer thinks that it is possible on theory, but to put it on technical world, it's a technologist or technician's duty to make sure that it's working as it is described in theory. So that's what it is for me. that's how I believe the engineering technologies.
I love it. So kind of going away or bouncing off of that, what kind of technical skills do you guys use on a day-to-day basis in your work, right? So, we're talking about kind of the more practical aspect of it, but what actual technical skills do you use on a day-to-day basis? Malav, what do you think?
So what I do right now, I'm working in an electronic printed circuit board industry where we design, there's something, let's say, for example, if somebody came up with an idea, I want to make a phone. So what we do is we design the things, then we manufacture the boards, we assemble, we buy the parts, and we make a finished product. So basically my daily job is I go through lots of design, like we review all the drawings, we do like use a lot of softwares to make sure that the design works. And then when the design is ready, then it goes to production. And when the boards come, we use all kinds of testing equipments to make sure that the boards passes functionality or it is working as it's supposed to be. So as I think a lot of students are using right now, like oscilloscope, signal meters, and all kinds of voltmeters and all kinds of devices we are using in like daily life,
So it's a lot of practical stuff that you learned.
A lot of practical. Actually, yes. Most of the electronic equipments that I learned in school, I think I'm using quite a bit of those.
That's awesome. I love it. Devil, what about you? What kind of technical skills do you use on a day-to-day basis in your work, in your job?
So in my work area, I have to maintain the time dissemination group. So what does that mean? So the cesium clock, the atomic clock generates the time, and then it puts out the perfect 1 seconds to the customers, to the clients, and in the lab. So there are lots of electronics equipment, and to make it more and more accurate and perfect timing signal, we have to come up with the new ideas every day. So I have to design the hardware for them. I have to design the circuit diagram. I have to design the PCB for them, and then I I have to put it in the lab and test it. So if it is working, then it has to be working 24/7. Otherwise, it will be in the newspaper next morning that the time signal is off. So yeah, so that's what I do. So it's quite a few it's a quite a uh, good work that I'm doing, that giving the time signals to Canadians.
That's awesome. Tell me a little bit more about that process. Like, how long does that whole process take from kind of the design to the implementation part? How long does that entire process take?
So it depends on the project. The one project I'm working on right now, it is running since last 3 years.
Okay.
So yeah, so it's quite interesting project. It's a remote. It's called the remote clock time link project. It's a small 8x14 box that we put our whole lab in the small parts and put it in that box, and we give that box to client, and client can use that box to that remote clock to steer their local clock to our time signal. So like let's say we give that box to stock exchange, and in stock exchange every nanosecond is like it's accountable, right? So if you do a transaction and you miss by microsecond, you lose $1,000. So we give this kind of service to our clients. So it's every day, like even in a red light camera, you get a notation to microsecond or millisecond. You were far from that millisecond and you get a red light ticket. So those are our clients who synchronize their time servers to our time servers. So basically the time, it depends on the project, but we have to make sure that the whatever we design, it has to be running 24/7.
Cool. And you work in a team, right? You're not working kind of in a bubble. You're working with other people as well.
Yeah, so in technology side, we are 2 people, and others are scientists. So
Gotcha.
so they do research on the most of the GPS parts and the rubidium or cesium oscillator, and then they give us they give us their specification that we need this and this. So one of us is design, like most of the time I am designing the hardware, and the other guy, he's from a computer, so he's designing the software.
Awesome.
Device, yeah.
Okay, cool. Let's kind of talk about your positions a little bit more. Malav, what do you like most about your current position? What about the least? Let's start with the most, and then we'll talk about the least about your current position. What do you like?
So the most thing I like is, every day that when the customer comes up with new products, like when they come up with new products, let's say they want to make this design, they want to do this. I have I have few customers who have designed few things, which right now are like, it was just an idea, and like right now it's like a big customer, like a multi-million-dollar company. So when you come up with new projects every day, this is like kind of, every day when you get a new customer, when I pick up the phone, when they talk, it's a surprise, and you hear new things, which is nice, which is the most thing I like. And as of right now, the only thing I don't like the most about my job is the semiconductor shortage all over the market, because we use a lot of semiconductor every day, and I cannot find the parts and everything, and I cannot finish the project. So that's the thing that I don't like right now.
And I think that's a pretty widespread problem over
it's a global problem. It's a global problem. And because basically because what we do is we assemble the components and everything on and make the product. So for us, not getting semiconductors, so our process stops.
Mm-hmm.
And that is where the major problem is. And that thing, I don't like it right now from past couple of years.
Do you guys have a way of working around it, or is it literally like you have to stop your project?
So what happens is, I would say 60% of the time we try to change the design a little bit and try to work around something. Mm-hmm. But on some of the projects, let's say, for example, some aerospace or medical projects, there's no way, because, even we work with the tolerances of 5 decimals, so if a little bit changes, So it's very difficult, on aerospace and medical. Even sometimes medical works out, but aerospace we cannot. So that's our main customer. So I would say 40% of the time the project stops.
Wow. Wow. Devil, what do you like most about your position after that?
I like most in my job position is like I do a design, I do a circuit design, and it's always unique. It's always I have to come up with something new ideas. I have to put new innovative or any ideas that is more accurate and the PCB designing I like most about what I'm doing right now.
What about the least? What do you like the least in your job?
Budget.
Budget.
Or that I struggle with that too sometimes,
Yeah, it's a publicly fund. It's public service company. It's public service federal department. So all the time we have to depend on the budget.
Right, and that's a budget that's probably put on by. It's like a departmental budget. It's not like you can go to a client and just ask for more money.
No, it's a departmental budget. It comes from the federal government. So
okay, and they have pretty tight purse strings, so it's hard to get around that.
Because what happened? Our department is not the time and frequency. It's not our services are most of them are free, and our department don't generate any revenue. They are not generating any revenue. So we are on the front page, but with the less budget.
I love it. I actually, something that both of you kind of mentioned, in terms of like the biggest challenge, or not the biggest challenge, but what you enjoy is that there's something new that happens all the time, right? So I find that I love that both of you mentioned that, because it is such a dynamic field, and there's so many different problems that you can solve. So I love that both of you kind of tackled that. And I know the challenge of the semiconductors and budget. So I get that too. But let's kind of talk about the process of actually solving these problems. So how do you tackle, like, beyond just, sitting down and talking about it, but like what's kind of the process that you go through to tackle an engineering type of problem? Malav, I'll start with you as well, or again, rather.
So for me, it's like one less, as I told you, like I always get a call that I have an idea and they give us everything on a paper and we have to make a product. So for me, every day it's just trial and error. So let's say I make a design, it doesn't work. I make second time, it doesn't work. I make 5 times, it doesn't work. So it's always trial and error. And at one point it works. So that's the main thing for me. My major thing is just trial and error all the time, and just trying to figure out what's the best and efficient way, even though it works, but sometimes it happens that it's not efficient, because when it comes as a complete product for a customer, it's not efficient or it's not budget friendly. So it's not that it just has to work. It has to work in such a way that when the finished product happens, it is efficient and budget friendly and works out everything. So it's just, for me, it's trial and error all the time.
How does that look though? Is it just like, is it software simulation? Do you go to the prototyping stage? Like what, would you get stuck at a point? Like how?
So what happens is, it's not just the software, because let's say, for example, if I have a design, if everything works on a software, let's say, and then it goes to a prototyping stage, and let's say, for example, all the boards, everything, if I have a printed circuit board with all the components ready, there might be a problem that, for example, some of the passives like resistor capacitor we use, because of such small components, the design is not acting as it's supposed to be, even though everything was okay in the software simulation. It happens so many times. Plus there's a problem, let's say, for example, somebody read the drawings wrong and made a prototype wrong, and plus right now their components are getting smaller and smaller every single day. So, it's so hard to see with your just eyes. So it's so easy to miss the problems, like cold solder joints, or some parts are shortage, or there's opens if the pins is not connected, So basically there are lots and lots of problems you go through with so many things, but as I told you, like there are so many steps, but we go through quite a few prototypes before looks like everything is okay to go.
Love it. Devil, what in your, I mean, it's going to be probably a little bit similar, but what is kind of that tackling of the engineering problem? Like what does that process look like in your workplace from start to finish? Give us the nitty gritty.
Okay, so in our where I work in our labs, we have equipment which is running 24/7 since 1980.
Oh,
Some
wow.
of them are working since 1975. I can read the date because whenever I make any device, I put my initial and my initial and the date when I completed. So when you have to fix those devices, that's a problem. So sometimes it can be fixed. Sometimes we have to replace with the new parts. So to fixing those devices is you cannot find anything on Google. Some of the chips are not there. Most of them are designed in microprocessor in binary languages. So it's very hard to fix. You cannot even interface. You don't have anything to talk to them. So yeah, we have to design a new device or something like that. But it can take time to. So we slowly started changing the boxes. Even they are working. We started already to change them, change the devices. So it's in good shape now. But yeah, to fixing a device which you haven't which is built before you born, so yeah,
So it sounds like there is a plan to kind of upgrade.
Upgrading
Okay.
the stuff. Yeah. So but
Are you part of
we
that
have
process?
lots of devices.
Sorry, go ahead.
So we have a lot of them. Our we are running one radio station as well, the shortwave radio, which
cool.
is which is giving 3 frequencies, shortwave frequency, and you can really hear the accurate time on them as well. So those are built in 1970s. So the transmitters are running, and we just have to maintain them. And some of the parts we don't even get them nowadays. So
Wow.
yeah, and we are short on budget, as I mentioned, right? So those kind of the things that we have to take care. And others, the small stuff like the whatever we design, we have to, whenever we put in the real world, it doesn't work all the time. So if we design, let's say if we design amplifier, and if we design amplifier, and when you try to test them, you put everything right on circuit diagram, everything right on PCB, you did everything right, but when you actually test them, there is always some problem. Yeah, the signal degradation is there, or something always there. You didn't put the right capacitor, or the manufacturer didn't give you the right product. So then you find the problem, and after finding the problem, it's really, sometimes it's really hard to find a problem, sometimes it's easy, but yeah.
And it sounds like, with some of this equipment that's from 1970, you can't find it on Google. I know you mentioned that, but it's not.
Yeah, we cannot find.
Just...
Yeah, we cannot. Even if we see the IC number, you cannot find that IC nowadays, or even not even a data sheet on that. So yeah, it's hard. So
That's
some of
tough.
and even that time in 1980s, they did some microprocessor programming as well in binary language. So
oh my God.
Yeah.
That's tough. So you're kind of, doing a little bit of everything. Like you're testing, you're probably using this equipment and learning new languages kind of as you go as well. That is right. Like
new as kind of new language, but it's very old.
Right. I'm fascinated by that old technology. I think that is it's so neat that you're still kind of like maintaining and troubleshooting and tackling that part of it. I think that's so cool. Okay, let's talk about explaining stuff. You guys all have clients, right? We all have clients of all types, but how do you explain these complex engineering terms to somebody who's a lay person? somebody who doesn't understand engineering whatsoever. So how do you take like a high level concept and something that is very, very technical in nature and kind of bring it to a level where the average person can understand? Devil, let's start with you. Like, how do you take those and kind of convert them into something that anybody can understand?
I haven't faced anything like that before because I don't talk to customers directly. So, but by giving an example, I can make them understand.
So if you explain to like your friends who are, if a friend that isn't in engineering asks you, they're like, hey man, what do you do? Like, what do you?
Yeah, so that's the question most of my friends ask. What do you do? Like giving a accurate time signal. That's not the job that you always do. But let's say I give you 1 kilogram of gold. How do you say that it is 1 kilogram? How do you say it's 100 gram even?
Right.
Like how do you measure it? Like the same way, how if I say this is 1 second, how do we measure it? It's 1 second, right? So you have to go to the laboratory to calibrate that equipment which measure the 1 kilogram or 1 second or 100 megahertz frequency. So whatever it is, like stopwatch, how do you say it's exactly 10 seconds? So you have to give that stopwatch to any laboratory to calibrate it. So our clients come to us to give those kind of instrument to calibrate for the calibration, and then we give them a report that whenever it's 1 second for us, it's 1.1 second for you guys. So that way they know that it's accurate. They're accurate. Yeah.
Cool. Malav, how do you explain things?
So I would say say similar with Deval, like we also do the same thing when, let's say, for example, we have a lot of university students who are designing products. And like just before like couple of weeks, I had a University of Waterloo students. They were participating some racing car competition. And they were designing some engine equipments for those, so some electronic parts. So when they started, okay, we want to do this, and then we started talking, you have to use this, you have to use that, and they did not have an idea what we were talking about. So what we had to do is, as Deval mentioned, we had to set up a conference call first to take them to our laboratory, and we talk about exactly what we're talking about, like what products to use, what actually the products does, what kind of semiconductors or what kind of motion sensor devices or accelerometers or microchip you have to use to make sure what you are looking for is this what you're looking for, right? And same thing, plus we also had to explain them, like they design few things like in the school, but the way they design is not the way the production works. Like they had a theoretical design, but when it comes to the production, it's completely different. So we had to arrange a conference call with the software that, okay, let's say, for example, if you do designing on a paper or on a, let's say, layout software, but when it comes to production, you need to have tolerances, you need to have aspect ratios, because it all, and then, everything has tolerances. Let's say, for example, making a simple printed circuit boards, there are a lot of things involved, like resins, coppers, golds, nickel, tin. So, all this has their own temperature levels, different aspect ratios, different tolerances. So we had to explain everything on the software, as well as during the production, we had to make sure that they understand because if you just design something on a software, it's not necessarily mean that it's 100% going to be the same on the production. So we had to explain them each and every single step. This just happened a couple of weeks back.
Do you find that sometimes you have to dumb down some of the concepts to get other people to understand it, or do you find that just explaining it as it is helpful?
So for me, most of the customers I get have at least some background of electronics. Okay. So, explaining, the only thing they have no idea about, for me, majorly I see they don't have idea of how the production works. If something is on paper, it's not the same thing on the actual world, right? Actual machine you're doing. So but explaining them when you go through the different concepts and show them exactly step by step, they understand what tolerances mean, what aspect ratios mean, what kind of things you want, what temperature you have to go through, and
That's
what
not too
kind
bad.
of signals. So
Awesome. Okay. Let's pivot a little bit, and we're going to talk about kind of you guys are both Seneca grads. So you graduated out of a program in the School of Electronics, Mechanical Engineering Technology. So let's talk about how engineering technology, how your education in engineering technology has helped you get to where you are today, because you guys are working on some really cool stuff. I'm sitting here and I'm kind of like, I love it. I think it's great. And I'm nerding out a little bit, but how did your education there, how did getting into engineering technology help you get to where you are today? Malav, go ahead and you can.
So for me, we have all these labs, like where we kind of do all the experiments, and like we have projects that we have to do. So that all the equipments help me a lot. Equipments, because measuring devices, all these meters and all that, this actually helped me a lot because of plus as I was just mentioning you, like nobody uses Visual Basic, but we were taught Visual Basic, and I'm still using those Visual Basic, which so many people in our company doesn't know, and it is really good. So a lot of things, even though if it's not used frequently anymore, but that's like Seneca teaches, is very, very useful. Like I found it very useful, all the equipments. And for me, the labs, the labs are the most thing. Like I really, like, I'm so happy that I had this labs, and that is why the couple of jobs I had, I was able to survive, and I'm doing okay with that.
That's awesome. And I know it's a little bit of a shameless plug, but we do try really, really hard to make sure that we have current and industry standard equipment in our labs. So
I think the thing is that we have, but if you think about it in real world, like nobody, let's say, for example, if somebody is buying some testing equipments, like as a company, they're not changing it for 15, 20 years, but so good thing about Seneca is they had some new equipments as well as they had some old equipments like Visual Basic. So this is a good thing that they have this old equipments, like even they will mention he's doing from 1975. So old things still help us, like it is needed, to learn.
So you get the whole experience.
Exactly.
Whole spectrum, right?
Otherwise, if you don't know, you have no clue like what exactly this is, so it is useful.
That's so great. Devil, what about you? How did your experience and your education in engineering technology help you to get to where you are today?
As mentioned, as Malo mentioned, that the practical, the lab is it's the same as it's the same equipment that we are using right now, like the spectrum analyzer, oscilloscope, those kind of stuff. The signal generator, those are the things we use before we start any project, before we start any circuit design. We put everything on the breadboards, and then we see that the signal is coming out, and then we start.
What are you watching?
Circuit.
Sorry, I think someone has a mic open. Go ahead. Sorry. Devil, you're muted. There you go.
Yeah. So it's kind of very helpful. The practicals were so those kind of stuff we do before we design anything. We put all the components on PCB and see that the desired signal we're getting or not. And we use all oscilloscope, multimeter, and the spectrum analyzer, and the time generator, the signal generator, and everything. And the other thing which helped me to get this job is my co-op terms. I did the same. I did the co-op terms in the same in the same area where I'm working right now, in the same company where I'm working right now. So which helps me a lot. So they didn't put any job on when they offered me a job. They didn't put any the job posting on the website. They just directly contact me because I did a co-op there. And Seneca has a rule: if you do a co-op there, you have to come and study for a semester there, right? So after completing my graduation, they called me. They offered me one year term, but just for a trial if I'm doing good or not.
And you've
Yeah,
been there
but
since.
yeah, yeah,
Is that the same place that you're at now as where you did
yeah,
your
yeah, the
co-op?
same place. Yeah,
That's amazing. And they reached out to you after graduation?
yes.
Success story. I love it. That's amazing. Okay, so again, kind of going along the same lines with your education, what kind of advice would you give to a young person who's interested in engineering technology or engineering in general? Like what kind of advice if you would give your 12-year-old self if you were interested in this industry? Devil, go ahead.
Yeah, I would say just study and do more, concentrate on practical side in the lab. Do ask as many as question to professor. You're not gonna get any time. You cannot ask if you are not asking any questions to your professor right now. You will not able to ask any question to your senior or supervisor. It won't look bad, but you will feel shy when you ask any question to your supervisor. Personally, I was shy when I was in college to ask any question, but then I realized it is better to ask questions to professor. They are there to give you answer, not your seniors. They have a work to do as well, right? So they can guide you, but they cannot give you answer, but your professor will give you answer. So I would say, and when you are working, you do your work in a way that your boss starting to feel like they are handicapped without you.
I love that.
So if you are not there, no one can do your work. Like
Right.
make that impression. That's what I say. Like anywhere, not just in engineering or not just in technology. That's what I feel. That's how I work.
Like a little bit of life advice from Devil Patel.
Yeah.
I love that you mentioned to pick your professor's brains, because I see some of my students in this room right now, and I love that you mentioned that, because I think it's so important. Like this is, that's kind of your opportunity to learn and grow as while you're in school. So definitely take advantage of that. Malav, what about you? Go ahead.
So I would say exact same thing as Deval, like just focus more on practical. Just don't think that, oh, you just passed the exam with A+ grade, you're good. Just try more and more equipments. If it fails, that means you're doing. If it's not failing, if you're just doing your lab, that means you're not doing everything. So just as they will mention, just play with the equipments as much as possible and ask as many questions as possible, and that would lead to a very good understanding of the equipments and the field you are with all the instruments. And as they will mention, I agree that, let's say, for example, if you're, let's say, in electronics field, and if you're thinking that designing is what you love, then try to just master in designing, like in such a way that nobody can survive. Let's say if you're working for a company, and if some design comes and if you're not there, then company cannot progress. So have such expertise that company is thinking that you are the one that handles this. It's also true that there's not a single person like a company that cannot replace you, but you should be expert in what you're doing, and it should be great. So just focus on what you're looking for. Let's say if you're just looking on doing some testing on equipments, just learn like everything, like just master it, whatever you want to do.
I love it. I wish you guys had given me advice when I was a kid, because I think that's amazing advice. So thank you for that. One last question before we kind of go into some of the questions from the audience, because I see that there's a few and we will get to them. I hope that we have enough time to get to them. How do you guys stay on top of currency, like of the currency of engineering technology and engineering topics and trends and stuff like that? Like, what do you guys do to kind of know what's going on in the industry, what's new, what's exciting? What do you guys use, whether it's a website or magazines or publication, whatever it is, but what do you guys do? Malav, let's start with you.
So I get quite a few like electronics and this OSET and then this quite a few magazines. Plus, as a part of my job, I travel to a lot of trade shows and a lot of customers. So for me, like just because of COVID, like past couple of years, I haven't been, but usually once a month or something, I'm traveling. So once a month for a couple of days, I'm traveling, and then I visit big trade shows that are happening. Like there are like few trade shows in Canada, like 7 or 8. I'm going, and then there are 3 or 4 in States. There is one in Europe. So I'm usually traveling to all these trade shows. So and when you talk with people, you know exactly what's happening, what kind of new machines are out, what kind of new testing equipments are out. So and all the companies. So yeah, that keeps me mostly up to date.
That's awesome.
Majorly,
Devil?
it's majorly. Sorry, interrupt.
No, no.
Majorly, it's trade shows. Majorly, it's trade shows for me.
Trade shows. That's awesome.
Yes.
Devil, what about you? How do you stay on top of trends?
So we go to conferences, like in physics, in my where I work, most of them are conferences, and the conferences give us a lot of knowledge. The researcher, the work they do, it's totally different from the work we do right now. Let's say we are getting accurate time signal here from, we are using 3 elements, cesium, strontium, and rubidium clock. And in other parts of world, people are using all kind of atoms to get the accurate time signal. That we don't know that we can get accurate time signals from those kind of atoms. So yeah, those kind of stuff that that get the conferences it's very much helpful to me to get up to date on the work I do. And most of the time when we choose a project, then we do bit of research that which is good, what part is good, and what is new to design. So so to stay up to date, we have to do a research.
Just a follow-up question, just about these conferences. I'm assuming because this is more research-based and more, you know, more federally funded and stuff like that. Are these more academic conferences, like they're hosted by universities and academics, or is this more industry, like more commercial, more for-profit?
It's mostly it's for physicists.
Okay.
The physicians, the people who work in physics and who work in labs, and it's mainly it's mainly based on the timing signal and the accurate accurate timing signal and the synchronization and the time comparison, time transfer, so all kind of stuff.
Awesome.
So, yeah.
Okay, cool. I'm actually going to wrap up. Thank you guys so much. I really appreciate this chat. I'm going to turn it over to Professor Karen Craigs. And I know that there are questions from the audience, so we're going to take a few minutes and maybe address some of those. There she is. But thank you so much for chatting with me. I really appreciate it.
No problem.
Thanks, Aggie. And yeah, this has been a great talk so far. We've had a lot of appreciation from the crowd. People are excited to hear how you're applying your skills and like using equipment and stuff. So thank you so much for sharing your experiences with us. Some quick questions to start. Do you have any recommendations for students who might be interested in joining a professional or a technical organization? Just
yes, I would say start with OSET.
Okay.
And because it's not like it's required for all the job, but you know, it is good to have it. If you're applying for a government level job, or let's say, for example, like a TTC or Hydro or something, they do ask for all this. If you're going for private companies, they don't, but it's still good to have because of the ethics and what they provide, what to do at the workplace. It's good to start with that. Plus, you get a lot of perks too.
Alrighty. Deval, do you have another, or would you agree?
Yeah, I agree.
Okay, cool. Thanks. Another quick question. Have either of you thought about going back to school to gain additional expertise in your field?
I am not going back to school, but I'm going for some certifications that are my company asked me, because we are in process of getting a new state-of-the-art assembly. So there are some IPC certifications I have to go through for a few weeks. Nothing other than that, nothing decided as of now.
Sure.
Same here. I didn't plan anything yet, but if my job, if I have to, if they ask me that you need the promotion and then they say you need master degree, then yeah, I'll go.
Yeah, okay. Yeah, so people are saying if you needed to go for like a degree or whatever, then you would probably consider that, right?
Yeah.
Oh, that's interesting. Okay, we have another question. What would you advise people who have already received their education in a particular topic like automation? How do they get a job, or any suggestion to find a right career path, for example, to automation? Do you have any ideas on that?
I would say, like, I don't know, like just try to look for, apply to as many jobs as possible. And whenever you apply for a job, make sure what they're looking for. Like, for example, for me, as I was being trained, as well as I was being told by so many people, every job I applied had a different resume, different skills, because you learn so many things, but you cannot put everything on 2 pages. So whatever the job requirements are, present yourself in the same way. Don't lie on your resume, but present yourself that, let's say, for example, if they're looking for, let's say, designing, then focus more on designing. If they're looking for some instrument knowledge, focus more on those. Put the other things, but focus more on what exactly they're looking for, and there are better chances you might get a response or an interview.
And it's Paul.
I didn't apply to many jobs. I just applied for 5 or 6 jobs, but I didn't get any interview or anything like that. But but during the co-op time, I think during the co-op hunting, I think one of the professor helped me a lot. I forgot her name, but I think there is a specified person who is helping to build a resume or something. I think she helped me. She helped me a lot to build the resume. Resume is the main thing that reaches before you to any place. So
Yeah.
that has to be strong.
And it's interesting that you guys pointed out about having a different resume for different applications. That's like an unknown tip, I think, and it's a great tip for students as well.
But just not to lie about anything. Just say whatever, but focus main what exactly they're looking for, because we have a lot of people, like, they put so many things on resume, but when you ask them, they have no clue. So don't do that, because then it's not good. It's gonna hurt your resume. But focus on what exactly they're looking for, and I would say they have better chances.
Quick question about your resumes. Was there anything that you were quite proud of that you put on your resumes when you were job hunting?
There were 3 things. First, for me, the 3 things. The first was my GPA. When I was looking for the first, my first skills was that I had a honor degree or whatever. I put that first thing. Then the second thing I put was the instrument knowledge, because as a technician or a technologist, you will be working with instruments, or if you're a computer engineer, you'll be working with programming languages. So if you're a programming person, then put more how many languages you know. And the third thing was what you, like a description of what you studied at your school. These were the 3 main things I had it on my resume, which landed me job.
Yeah, I would put more and more about the project you have done or the experience you have from the past. So especially when we were looking for a co-op student last term, and the main thing I was looking for the projects that you have done in school. So that gives us the idea that how much you can work on practically on equipment. So let's say if you have design amplifier, which is great, we do design amplifiers. Even if simple amplifier, that's okay, but we design complex. But if you have not designed any amplifier, then it's hard for us to make them learn to design from the scratch. So it's good idea to put the projects you have done. And I did quite a lot project. I did like 5 or 6 projects when in bachelor, and I put all my projects on the resume.
Awesome. So kind of like a practical portfolio
Yeah.
of projects that you've built. That's
Yeah.
awesome.
Yeah.
I've heard that advice before, and it's nice to hear it again, actually. Thank you.
Yeah.
I think we have time for one last question. Can you tell us a little bit about your teamwork environment? Like, do you get help from your team at work? If you had a few sentences to say about that, what would you talk about for teamwork at work?
So yeah, we get we always get help from coworkers, and we help them as well. Whenever we have questions, we can go with the plan and then ask them without directly asking them what's the answer to it. So yeah, and the same with the question comes to me, that I ask them to prepare the plan and then ask me the question. Directly saying that how to design amplifier. Just don't. Yeah, so it's kind of that. So we get help. We get a lot of help from the coworkers. Yeah.
For me also, I would say, yes, teamwork is very, very important. It's better to have 2 electronics minds at work instead of 1 when you're troubleshooting the problem. So yes, teamwork is really important, and it plays a major role. So it is good to have a good attitude and a good understanding with your team. So in order to make your life easy at work, I would say teamwork is very important.
Awesome. Thank you so much. Aggie, I think we'll pass it back to you.
We are going to pass it back to Dr. Rakesh to wrap us up.
Okay, thank you so much. It was really amazing. Let me add the Aggie as well. So then we are pretty much done with this program. I learned a couple of things for all the students who are here. They say you need to work towards your project, not to just get a grades, but actual work to show the project work. Because when you are preparing a resume, you do not have a whole lot degree. But when you talked about the project, and as Malo says, don't write down the project which your buddy had did it. You write and mention the project which you did it. Okay, so that's very important. Second thing, they will ask, ask a question. Karen or Aggie or me, we are not charging extra money when you're asking us a question. So it's always a good idea that you ask the question to your professor. Be realistic in your resume. When you're preparing your resume, it's not like it's supposed to be like a so decent, but it's supposed to be, as Malo says, every single word of your resume, you're supposed to know it's your own resume. That's the most important things. And regarding the certification, OSET is a good point to start up. And another good thing is just a student membership is only $50. As soon as you graduate, that 50 become 250. So that's an additional thing for you.
It's
So
300 now.
You can just start.
That.
Yeah, you can just start it while you are in the school. So you just start with the $50 and teamwork. And that's why we are assigning, the different people to work with a different team. That's how you learn. Not only, the sharing technical stuff, but you also know how to deal with another type of human being. Okay. So yeah, that was a really very insightful, Malav and Deval. It was a really extremely, learning experience, as Aggie asked a lot of different questions, and it was really mind-blowing. Many of the things we also learned. We really thankful for you, because despite of your busy schedule, and right now is your family time, you spend the time with us, and you spend the time with the Seneca student. It mean to a lot, and we really heartfelt gratitude from the summit from Neosa and the Romel that you are here. So we are thankful for that. And same way the Karen and Aggie, you did a great job, asking a lot of questions, and it make an event so lively. And we were preparing from quite a couple of weeks, I see a couple of months, but yeah, we did it everything proper and nicer way. So with that, all the participations, I'm sure that you learn a lot of different things. You will get a lot more. Follow the advice and keep moving, and we will working towards how we can have more and more this kind of event. Once again, thank you so much, Karen, Egi, Malav, Deval, and Summit team. Thank you so much.
Thank you very much.
Thank you.
Thank you.